Okay, welcome to Similar Triangles Day 2. In this case, we are going to be proving that corresponding sides of similar triangles are in proportion. And it's very, very similar to corresponding parts of congruent triangles are in proportion. Instead of proving the triangles are congruent first, we're actually going to prove that the triangles are similar first. So, in order to do that, we're going to use angle. And if we want to prove the triangles are similar, we're probably going to prove triangle ABC is similar to triangle EDC. And the way we do that is certainly look for angle. So I've labeled the first two givens, and I'm probably going to use vertical angles for angles 3 and 4. Let's take a look at the proof. Angle 1 is congruent to 2 is given. 3 is congruent to 4. Vertical angles are congruent. And then I'm going to prove that the triangles are in fact similar from angle. And then this next statement and reason is the new part of today's lesson, which is the fact that AB over BC is equal to ED over DC because corresponding sides of similar triangles are in proportion. So this is a new reason. Please make sure you're making a note of it. But corresponding sides of similar triangles are in proportion. Now, there is another thing here that I could say if I really wanted to, and that's the following. If I wanted to, I could say that AB times DC is equal to BC times ED. And if you think about it, someone just came along, and in essence, they did what you've all come to know and love as cross multiply, but in the real math world, we like to call it the product of the means is equal to the product of the extremes. So you're never really allowed to say as a reason, I cross multiplied. Instead, you would say the product of the means is equal to the product of the extremes. So notice I just cross multiplied and got AB times DC is equal to BC times ED. Let's take a look at the next page in your packet. I'd like you to write these down, please. So I'll wait a minute while you copy that. Okay, so I think it's pretty clear that you're supposed to label the givens. This step number 2, we're going to put a little star next to that. We're going to go over that again at some point. But step number 3, determine which sides you need to prove proportional, and use, if two triangles are similar, the corresponding sides are in proportion. Determine which angles you need to prove similar. Use angle, and then when you are short, look for reflexive or vertical angles. Don't forget the easiest reason, which is in fact given. So let's take a look at the next page, and I want you to label the givens, please. So I've labeled the fact that lines are parallel, and we have that angle 1 is congruent to angle 2 based on corresponding angles. I'm going to use reflexive on angle 3, and what I'm going to notice in this case is that we're going to certainly prove that triangles are congruent based on angle, and I probably want to prove that triangle AEC is similar to triangle DEC. And then I could certainly say that the corresponding sides are in proportion. So let's take a look at the proof. So first we do parallel, because it's given. Angle 1 is congruent to angle 2. Please make sure you notice it says the corresponding angles are congruent. So very important that you realize it's corresponding is congruent. So it doesn't say alternate interior, it says corresponding. The next thing, angle 3 is congruent to angle 3, and that's based on the reflexive property. Then we're going to state that the triangles are similar based on angle. And then the last one, which is our new reason, that the corresponding sides of similar triangles are in proportion. Now think about what I could say if I wanted to, if I cross-multiplied, or if I did the product of the means is equal to the product of the extremes. I'm going to say that EB times CA is equal to BD times EC. And again, the reason would be the product of the means is equal to the product of the extremes. Now try to realize or remember, technically, the proof was done here, because in the original proof, it just asked us to prove that this part. However, I took it one step further, and I'm just explaining to you that we could do the cross products being equal. Okay, let's take a look at the next one, please. So I've labeled the givens. The fact that the lines are parallel and that created alternate interior angles being congruent. I also have vertical angles congruent, and that's angles 3 and 4. And then I could say the triangles are similar, so I'm going to go triangle JAM is similar to triangle LDM based on angle. And I'm also going to say that the corresponding sides are in proportion. So let's take a look at the proof. Given two parallel lines cut by a transversal, alternate interior angles are congruent, vertical angles are congruent, triangles are similar from angle. Please make sure that you have congruent right here. And then the corresponding sides of similar triangles are in proportion. Lastly, if I wanted to, I could in fact say that DL times AM is equal to DM times AJ, or the product of the means is equal to the product of the extremes. Again, this proof would have stopped at step 5, but I'm just showing you one more step here so that we will now know how to do the next proof.